Okay, so I understand that it's streaming now. Oh, that's pretty cool. Okay, there we go. Oh, turn the keyboard off. Let's try that again. Okay, so is there any good volume? Okay, so is there any good volume? Blah 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 blah. Let's see. Advanced audio properties. Hey, you're gonna have to tell me how loud I am. I should look up there. Let me turn that up some more. Whoops, I got rid of that. How's the volume? Okay, let's try doubling that again. Properties. No. We've got a little widget here. We'll just. Ah. I thought I'd reset the dial. Let's see if I can set it to 8 again. Does that actually change anything? Yeah. Blah blah. Talking. No, it's not hitting the 8. Let's try 16, which is substantially louder. Blah blah. Oh, I probably need to lean forward a bit. Okay. 20. Is that working? Oh, that's better. 24. Talking. Oh, there we go. I hope I'm not making you deaf now. Let's leave that alone. Okay. Well, this is kind of weird being watched. So, can you hear me okay? Yeah. Okay. Well, as long as you can understand, that's fine. Let's have a quick look around. It's nice you're here. So what have I got? Player input actions. I think probably the first thing to do is just to wind back the clock slightly and just set up a quick demo. So I need to create a temporary commit of the things I'm working on. Thanks. Yeah, I thought it would be a bit boring if I was working off screen too long and you couldn't see what the hell's going on. Okay. It's also half the resolution, so hopefully things are somewhat readable. So I'm just I've deliberately made a commit here of my new code. I was going to check out the slightly older code. Check out, because that code is reliable. And with that in place, I should be able to go over here and run a server, which is compiling and the game, like so. So these are just batch files that are currently launching. Probably I might want to move the camera across where, making eye contact. Okay, so the game is compiled and launched. So you can see, and if I was to launch it again, So there are 2 copies of the game here. So we'll just put that one over there. Yeah, that's the plan. I thought that would make life easier later on. So this is one game client, and here's a completely separate version here. So they both got their own console windows, but we don't really care about that other one. This one here is that guy's, but I'll put it back over here for now. That's the server. There's a client. You can see the ship is moving because of the physics. So these 2 ships are moving apart, and I've got my little person. He's just standing out in space. So I can place him in the ship. I can move him around. I'm using the cursor keys to move him around. He clips through everything right now, and that's currently not synchronized in any way. So if you look over here, you'll see that this player is actually independent because it's only in go.code. It's like experimenting. But what is synchronized is, this movement's going to get really annoying eventually. What is synchronized is building stuff. So for instance, if I build conveyors here, if you look down here, you will see that they appear. If I build a storage container, or I build a scoop here, then it should create gold. So you can see gold going on the conveyor, and then I put a storage in place. It goes into there, and then I can build conveyors. Let me just move to follow the ship, which is drifting, which is these keys. So build some more conveyors, build a little refinery. Okay, that's a really good point. Thank you for pointing out the overlays. It's easy to forget that they're there. In fact, I have to think about how I'd stick something private down there. That's the server. I have to change my background to paint a little red box down here or something to remind me, do not go there. Anyway, let's follow the ship. So if I put a refinery in here, and then I put more conveyors, gas or some more floor space. So if I move this one, you'll see that everything I'm doing so far is synchronized. And build some more conveyor, and another box. So this movement's really annoying for the purposes of demonstration. This little box collects all the stuff together. And then later on, what they'll be do is, thanks. Yeah, so it's going to be really exciting when the next thing you can do is build a flight desk. There we go, this guy. So we put him like this. And here we go, let's get rid of that. And we'll move him so that he's close to the flight desk. You see it turns out with a little use E animation. But pushing E doesn't do anything. So down the track, when I push E, it'll send a message to the server that says, this flight desk is now usable. What's it called? Sorry, no. The view will zoom out. So it'll zoom out and take on the perspective of the ship, and you'll be able to fly the ship around with the cursor keys and so on. This is all very interesting. There must be parts of the ship I put in testing that have just ended up over here for some reason, some sort of synchronization bug. Yeah, odd. I don't know where those have come from. I might have clicked by accident at some point or something. There's currently problems where you can build modules on top of each other and so on. Because I haven't done any constraints on what's physically possible. You also delete walls because, why not? It's only space after all. But if you build more floor, then it works out okay. Building floor into components doesn't work out well. If they share the same piece of space. Floor build, it'll just leave a gap in the wall. It's like double building on the same place. Oh, I keep stuffing this up. I mean to delete this floor. There we are, that's what happens. Of course, again, everything is pretty much the same on this one. But the state synchronization of the floor, I haven't written that yet. Because I thought, well, I'll put that off. But once the floor's done, it's some other state synchronization I haven't done yet. What haven't I done? Oh, that's right, it's conveyor contents. So this game's currently running forward in time until it catches up to the server. I think it has. And oh, these guys are. That's really cool. Actually, the ship had moved. I did not think that synchronization would work, but it worked fine. That's so cool. Okay. So what I'm just commenting on is that this ship is in this vast space, like they're far apart on this new client that I just created. So that was great. Done through the virtue of running time forward really fast here. So just like run all these ticks since it started up. So basically fast forwarded everything to tick 6,000. Oh well, catch up. It'll be better soon. Does it synchronize positions? It might be that it synchronizes positions, I'm not sure. Anyway, so that's the game as it stands at the moment. This goes on his little space journey. We'll just leave one of space journey over here for now. I didn't just close the server, did I? No, I don't think so. Oh yes, I did. I closed the game. Oh well, too bad. So let's have a quick look at the code repository. Goodbye server. Alright, close this. Okay, so the ores are handmade. So if we just jump into Blender. So for the ores, let's find it. Oh, I just lost my Twitch chat dialogue. Where did it go? Okay. Let me just try. I might as well put a tweet out actually, just real quick to just say I'm streaming. Okay, there we go. I announced it on Twitter. So absolutely no one's going to come. Okay, now let's have a quick look at this. So in my C drive, because I'm on Windows at the moment, because I like the developer tools, C drive, game dev, where are we? Yes, game dev, Star Factory. We've got a number of folders here. I wonder how much. No, there's nothing really private here. We've got the game itself is in here. That's the Blender folder. That the game is the folder that all the stuff to do with Godot's in. And then we've got another one which is RS. That's where all the Rust code is. And we've got one here called Blend, which is where the blend files are. So we're just going to go into the blend files. And in the blend files we've got asteroids. Did I put in shape drafting? Or yes, rocks. So here's the rocks that you saw before but textured. And if I just quickly make those smaller, so if I these are a blend file, if I file export, and I exported them here as obj, and these are all skinned. So these are handmade. I just sculpted these. So I'll pop that over here for a second. And then Substance Designer, which is going to take a little while to load. Connecting. So if you look at the UV editing, no, I don't need to submit a crash. So you'll see these are the scenes. This is tries. Okay. Create. Or gold. So the short version is that I started with a dirt texture that is here. So here's a substance graph. Here's what the texture looks like. It's lagging a little bit. There you go. Here's the texture. The texture looks like. If I go into the ores project, resources, ingot, rocks. That's the one I'm thinking for. If I grab the ore, that's what they look like with dirt on them. Oh, it's just put gold on them. Let's go back to dirt. Send that to 3D view. That's what dirt looks like on those rocks. And then I created a number of other graphs that do ore. So yeah, here's what gold looks on these. And yeah, and the way it works is quite straightforward. It's like a lot more straightforward than you'd think. So in this one I've just got the setup for these rocks, and then in here I've got flexible order, and I've got a different set of attributes for each one, and all of them. So if I look at these rocks, I can go, this is what they look like with iron ore on them. This is what they look like with nickel ore on them. Cobalt. And yeah, that is what cobalt looks like. Ice. And so I try not to get too fixated on this, because most of my games are going to be like really small on the screen, so they don't have to look perfect up close, and actually the resolution of the textures is quite low, so if I increase that resolution I should get more quality. They look better close up. So that was granite, this is slag, which is what comes out when you make gold, and finally quartz. And so I use a program called Quadro, which is basically just holds pictures on the screen, and you can probably see in the little view of the other screen here. So if I just go to this, all my reference pictures have come up on this other monitor. So for instance, here's the reference I used for slag. So if I go to the slag, and I used it in the sense of I looked at the slag picture and then I tweaked the settings until I was happy with the output I was getting. Let's put that always on top. Where are we? Always on top. Here's the one for gold. Put that always on top. And so, you know, you tweak these things forever. Yes, the ores are 3D in Godot. So let's go through how that works. So when I make an ore, I choose from the ore output, this option, this output option here, to, where are we? I think I choose it here. Right click and you choose export outputs as bitmaps, and you specify the outputs. So, and just have a look at those outputs real quick. So on this right hand side here, you can see all the different texture maps that are created, and you've got base color, normal, roughness, metallic, etc. And down the bottom, I've actually used an RGBA merge to pull in various channels. So RGBA merge contains roughness in red, metallic in blue, and ambient in green. And they all come out as one texture. RMA height, so R, roughness, metallic, ambient, height. There's a depth map as well. And then there's the albedo, which is in color, and the normal, which is in color, and then all these other ones I don't usually bother to export because I've got them already. And so if I export as bitmaps, I choose the ones I want here. They get turned into pictures that go in this folder. So let's just quickly open that folder. So here's all the different outputs. So if we have a look at gold, let's look at gold base color, I think it's called. So that's what it looks like in base color. So if I go back to Blender, and I'm in UV editing mode, and I scroll across, and I select all asteroids, you can see that that's how the UV maps are unwrapped. So you can see that there are areas here. Okay, so then when we go to Godot, which I'm just launching, No, that's not Godot. Let me just put this in Discord real quick, now that I'm thinking about that. And absolutely no one's going to turn up. Anyway, that's fine. Discord, at least I've got one fan. One fan! I'll do anything you want, just stay. Okay, let's quickly launch this. Recall Singularity. Okay. Not responding. Why is it not responding? Don't do this to me. Oh, it's loading all the textures. Okay. We'll just patiently wait while it loads all the textures. Okay, so that's the scene. So I'm just showing how these asteroids are loaded into Godot. So if we go down into space, I believe it was, I put them in mesh. We've got rocks. So this is the rocks file. This GLB file came straight from Blender, but what I did was I made a rocks scene. So when you open the rocks file in Godot, it creates this. When it came across, these were all white, so they were not, there was no material on them. But what I've done is I've gone to each one of these. We look at the material on the right hand side here, and in fact, let's just go through this process real quick. Stream category to science and tech. That's a great idea. Channel dashboard. How about we try that after I've done this quick little demo? Reconstructor, that's a great idea. Thank you for mentioning that. We're going to create a new inherited scene. So this is what it looks like straight out of Blender. So there's a simple export to this format from Blender. And if you look on the left-hand side, you'll see that it's kept the hierarchy from Blender. You probably didn't notice the hierarchy the first time, but I named all the rocks. And if there were lights and cameras, they would have come across too. So they came across with the same names here. Put in a scene. So that's what the GLB format does for you. If I choose a rock and I go to mesh, I've got a material, and I go into the material and I can say new spatial material, which is like the best, and then go into this. It has so many options. So I'll just quickly set up as a PBR material. So let's see, I think we don't need to choose anything from this. We go to albedo, and to do this, it's easiest to go to our file structure on the left here, go to space, go to materials. Oh, I renamed that. Material, PBR. There we go. That's what I was looking for. It's worth noting, I've already got all these materials created over here. So I could just go gold, splat like this. Well, actually, I have to copy it up into here. So grab this gold, go up to here. Blink, it's got gold in it. But I'm going to do it from scratch. So, albedo. So we go into PBR. We go into gold ore, which is here. Grab the base color. Base color is albedo. So now it looks like it has the colors of the rock, right? Then we go down to metallic and we grab, there's a metallic one here. Oh, that's right, that's what we do. So we grab the RMA, because remember we made the RMA one. Don't know why I called it RMA height. Oh, that's right. Yes. So in the red channel is roughness, and the green channel is metallic. So that makes it shiny or not shiny, or metallic or not metallic. Roughness is what makes it shiny. So we put the same texture here, and this time we're going to choose the red channel, and then and this is not going to really look very great until I add a light to the scene. Omni light's what I want, and we'll move it closer to the rock, and I'll place myself in a nice position so you can see. You can kind of get an idea what's going on with this rock and this light. So we're in the material. Normal map. So that's not going to do much. The normal map is really essential. That's why you can see the triangles, is because the normal map's not in place. So we'll put that in here. And so if I grab this light and move it now, you shouldn't be able to see the triangles and the lighting. Well, you can kind of hear. and back into here. We don't need emission because it's not going to glow, but if parts of it glowed, you just create a texture of what glows. Rim, we don't need that. Clear coat, androscopy, ambient occlusion. Oh, this one's a good one. So you turn on ambient occlusion and you provide a texture of which parts are dark. I believe ambient occlusion is in the RMA texture as well as A for ambient texture. So A would be blue. And so what this does is add some subtle shadowing here where the model is self-shadowing, which is one of the wonderful things about Substance Designer, is that all the noise, yeah, they do. They really do. All the noise is going into that ambient channel. This rock isn't very messy, but this one here, which is, when these are very low resolution texture maps, it's more obvious with the floor. In fact, I need to redo the floor because that was my first ever attempt and I just used off-the-shelf stuff. And I've even got a depth map. This is really hard to use effectively. I'm not sure if it's better or not. And it took me a while to actually get a depth map that I was happy with. I come up with something really subtle. And you need to turn down the scaling because it looks like, if we just focus on this little triangle here, it looks kind of like the rock is underneath the mesh. So it kind of pulls the rock into where it should be. So it creates this weird distortion. But it probably looks really great from far away. But at the same time, I'm not sure if it looks better enough to make it worth the trouble. So, oh well. So that's how we get those in. So these guys are all, yeah, that's exactly what it's like. It's like looking into a transparent block and seeing a rock. A rock and a crystal. That was nice. I like that. Okay, so scene root. How do I get the meshes? Okay, so let's just jump over to, I think I mentioned the names. I create the scenes and I mentioned the names. That's how I pull them out. So let's have a look at how we instantiate those. Because if we look at how we'd instantiate them in Godot, we can go quickly into our file system. I've got the 3D root scene, but I've also got, by the way, that lawn and sky, that's what provides a lot of the lighting detail in the actual game, but you don't ever see it. And if well, I'm not sure why you can't see the background. Oh, I think I turned the background off. So there's your background. So it's just a number of layers like this. And then as the camera moves, it provides nice parallax like this. And then there's some code that slows down the parallax effect so it works over a larger area. So let's go to my 3D experiment. I'll just turn off this background again because that way, you know, it's a bit distracting. I don't know, should I turn it off for streaming? 3D Rock Test 2, that's probably not the right one. Nope. So many of these, and I forget which one is my current one. My old experiments break after a while. So this is my current experiment scene. Things look weird in here if you're used to the game because the camera has a weird fob. So we can go into the settings here somehow. Let me just remember how to do this. View, settings, perspective fob, set that to 20. In fact, it seems to have saved it, which is why everything looks so square. Well, these gizmos are awful. Get rid of you can turn the gizmos off like lights. I can almost see the camera if you look closely. But that's what provides the kind of straight view, as opposed to if I went to settings and set the FOV to... How do I repeat them? Well, when it comes to the background, so if we just jump back to the background, we make this visible again. If you look, you'll see that I am already repeating them. See, this planet is here, and then down there, and then down there. But this is just a placeholder. The plan is going to be to actually have a generator, like, you know, a Perlin noise or something similar, that's constantly creating these tiles as this camera scrolls and goes off the edge. And the way you repeat them, if you look at the scene tree, each background is basically just a texture. So you've got a mesh. So, you know, as in create a new plane mesh. So you just go plane mesh, you know, flat. And a material, and the material, all it's got is albedo, and it has transparency turned on. It's unshaded, we don't want it colouring. It's vertex lighting, again, no colouring, don't receive shadows. Disable ambient light. and a texture. And so later on I'll be instantiating these, like I'll be rendering to the texture somehow from Rust, and then as you scroll they'll just go on and on forever and show a nebula. It'll be gorgeous. And there'll probably be some top layers. I mean, you know, particle effects are going to be very important to sell the asteroids. So if we just jump back to conveyor and box, this is what the scene looks like for testing. Here's all the different rocks. In fact, in this case I think I just grabbed the entire scene. That was the rock scene. So let's jump across to some Rust code. I got a tip of the day, actions, floor tiles. This should be fun. I mean, you know, first time I ever shown this much of what I'm doing. Yeah, what could possibly go wrong? Okay, so I was going to show you the bindings. So if we focus on what's going up here in SG Core, and I've got 3 classes that Godot knows about. We've got 4 tiles, ship link, and star world link. So if I go back into Godot and I push run, oh, it's not going to actually work because the server's not running. So I said quickly, was the server running? I can't remember if I killed the server. Let me just start the server again. Okay. Sometimes in the rush to load, the integration doesn't notice the event saying the floor has changed, and so it doesn't render the floor the first time. Simple bug to fix. I haven't got around to it yet. There's a bunch of little things that I just haven't bothered to fix because I thought, you know, what's the point? Again, the ships are flying apart. Because the physics tick has got a constant velocity on each ship. What are they going to show you? Oh yes, that's right, the scene tree. So if we go here to remote, we can see what the scene tree is. So we've got root, we've got ships. Ships has that Star World script running. We've got ship 1. Ship 1 has ship 1 and ship 2 are created based on what ships were found online. And so each one of those ship 1 and ship 2s has an instance of the ship link. And then inside each ship, we started off with a scene as a, there's actually a ship scene in here somewhere. It's been a little while since I had to worry about the ship scene. But there's a ship scene, a ship root scene here, which is loading. So the ship root scene still has lights in it. Ugh. I need to get rid of those. In fact, why not do that now? So let's just delete those. Delete. Okay, save. That's why this origin is so bright, because it has that lighting in it. And this down light as well. We don't need that either. Delete, delete, save. And you can see that it's actually changed things straight away. Because what's actually going on for lighting is that in Rust I'm creating lights based on where the floor is. So when I build a floor, it actually adds lighting. There's like a grid of where lights should be. And when there's enough of a grid, it creates a light above the relevant place, and then it places it over the ship. So you get some sort of dynamic lighting that's based on the ship's shape. And if the ship is like long and thin, you'll end up with these areas that aren't even lit, I think. I don't know. Maybe I'm just very lucky. Oh well. Okay, it's so much fun I can't stop doing it. Anyway, oh, and in case you're wondering, there's not really a reasonable size limit to this. I probably need to put some in. Again, I'm just too many walls being created. It's broken the updating. Anyway, and there's a few glitches, but it's probably just to do with debug output being rendered. Anyway, that's what Rust does for you. The part where it does tons of stuff at once really fast and figures out how to put the tiles in with my little algorithm without it lagging out. Where was I? Okay, so for each ship, the ship is running a script. So if I look at local and I look in, oh, that explains a lot. I probably deleted the images, the lights that have been created in the scene. I wasn't deleting. I was deleting the lights from the actual game, not deleting the ones built into the scene. The ship root has a script. The script is so if you look at this ship root script, it's an actual script. Oh, that's right. I've got a floor tile script. So that refers to SG core and has the name floor tiles here. And then I've got the floor script, which is called ship link here. So these names that are written inside of these links are what has defined the class names in Rust. So if I jump back out to Rust, do I want to leave this running just so you guys can watch it? I mean, the good ship Gigantus flying past. Let me delete some floor so that it's kind of more interesting. Again, there's events being sent, but I've got a limit to how many events can be sent, and the amount of walls that are changing is too high, and it's bugs. So many bugs. Why is it deleting the floor? Okay, let's ignore that. Everything's fine. Hey, Ardawan, I'm glad you could join us. Need a big, like, pew, fireworks. Oh well, hopefully there's some way that you can, it will save. I imagine you can watch an old stream. I have told my computer to save this as a recording, so I could probably put it on YouTube and you can watch it later. We'll see how that goes. I mean, it might not work, so oh well. Maybe next time I have to have a schedule for when to stream, I guess, because now I'm a legit streamer and all that. Anyway, where was I? I was going to show you these scripts. So there are 3 scripts that we have for binding to Godot, and they are a mess. I admit it. They're basically prototypes. We've got completed 2 achievements. Interesting. Okay. Star World link. Which is what created the ships. That's why there are actually ships in the first place. It creates them when the ships get, and it's also the one that's moving them. We've got one called ship link, and it's the one that's building the modules, and it's placing them on the screen. Yes, the schedule's essential. I agree, other one. It's placing them on the screen, and it's passing in the actions that are from the UI. And we've got one more, which is floor tiles. Let me put it on this side. And floor tiles is allowing us to, well, it's basically, its job is to update the tiles. So if the user changes the tiles, they will call update tiles. And when they do that, it will create an action, and the action will get sent to the server. And then once the server has made modifications, yeah, okay, font changes, tools, file, it is really tiny. I mean, I've got a big monitor, settings, editor, font, size, let's go to 15, okay, hopefully that's better. Wow, it's so huge. Okay, I should like hold up a mirror so you can see what I can see. Anyway, floor tiles, update tiles will go through and draw new tiles when it happens. How do we do this? Okay, I just need to take a bit of time to think because it's been a while. You went to a font size of 22. Well, yeah, I mean, it's a 4K monitor that's being downsampled to a lower resolution, so that's probably not helping either. Let's try that. Settings, font, size, 20. I could probably live with that for a while. Yeah. Holy shit, that's huge. I can live with it for now. Anyway. So what does it do? So, and to be honest, it's quite ugly the way this works. So, all my state is currently held inside a class called inside a file called singleton. You create this thing called a global sector, which is a mutex containing a box containing a sector, and a sector contains a map of worlds, essentially. And so what happens is in clone current floor, we get the singleton sector, which could lock the UI, the GUI thread. So one thing I'm thinking of doing is moving all the, right now we've got network code on one thread, Godot's got its own internal threads and it calls us, and the network thread and the Godot thread both lock the singleton. I really dislike that idea. So I think what I'm going to end up doing is actually have the Godot stuff have a singleton that owns the world, and it calls the network thread and it pulls the world, and so there's no global singleton and there's no mutex, and then the sharing gets a lot easier. Anyway, so for the floor, we just grab the sector. If we get the sector, we call clone floor squares, which returns us a floor. So we get some floor. If we can't find it, for some reason we get no floor, which is pretty much not going to happen. And then here we are. If we got a floor, with the floor resource, we clone the floor, we find the tiles that need to be placed in the, oh my god, in the GUI thread. Why did I put that in the GUI thread? Oh well. We find the tiles that need to be drawn, so that figures out how to tile a large ship. So if you look in this, what we're doing with these tiles is we're determining these 4x4 tiles of floor here. Or this here is a 2x2 tile, or here are 1x1 tiles. My cursor's not moving with the ship. See add-on. So that this code is creating those tiles, and then down here we're actually going through and placing the tiles on the screen as meshes. So it's creating those. So for tile and tiles, we figure out its tile and its offset. So that should mean we know where it is, and then we set this member called self tiles. So that's a vector of ship boxes. So ship box is basically a left, right, top, bottom. So that's where the tiles are going to go. So that's just a pure algorithm. So I could easily throw that into a different thread. So I probably should set up a lambda in a thread and put that somewhere else so we don't lock up the UI while we're doing that calculation. And then down here we've got we into some unsafe code, because everything to do with Godot is unsafe because of FFI. We try and get our parent, the parent for 10x10 tiles here, and then turn it into a spatial, which is a class in Godot. So if I just to give you a quick thought, if I open up, oh gosh, I'm glad there's nothing dreadfully revealing about what that's showing. Anyway, if we go to docs.irs, so much you learn from streaming. And we're going to look for Godot Rust or Rust Godot. Getting a warning about my D drive space, probably running out of space because I'm saving a gigantic video file. Let's have a look. This PC. Oh my god, I really am running out of space. Hopefully that doesn't cause any problems. Yeah. We'll see. So, okay, what's it called again? This module. Toml. You know, Toml is like my name. Tom, Lees, Toml. That's quite funny. Anyway, this is the workspace. I wanted cargo core Toml GD native. So I'm using Godot Rust. So that's what I look up in docs. Is Godot Rust. Okay, so we're just going to go back to Godot Rust on Google. And if we go in here and have a look at Godot Rust, we go to docs. GD native. Okay, obviously. And we look at spatial. We'll find that spatial is a 3D node. And we can find all the members of it. New, set rotation, set translation, etc. So with that with that documentation available, we can go back to floor tiles. Let me just focus on this one file. And we can go down here and we can see that what we're doing is we're finding, we call owner.find node. So this is part of the node class. So if we wanted to find node, we're looking here for node. Oops, I'm doing this wrong. Duplicate. Search node. And in here you'd find node. So this is the main way that I get from one node to its children, as I use find node and I pass it a string. So I'm trying to find a child called tile 10 by 10, which becomes our parent. If we look in remote and we look inside a ship, we look inside floor tiles, you'll see we use tile 10 by 10 to hold all the tiles, like so. Let me just find this ship again. So each of these tiles is within this tiles 10 by 10, and on a regular basis what we're doing is we're actually creating and deleting these tiles. So first we find the parent, and then with the parent we go through each mesh. So we've got a map of scenes, and the scenes contains this tile, this 10 by 10 tile. So right now I've only got one tile I call 10 by 10, but down the track I'll probably have multiple meshes that I place inside a ship to make it more interesting. And then with the mesh placer, I just place it all over the place. Here we are, place tile at the tile coordinates, which tells it left, right, up, down the track. This is going to give us, we'll basically have an outer loop here that goes through all the different types of tiles and places those tiles with meshes. And this tile placer takes care of, mesh placer, sorry, go across to here, is a class that understands how many children we have, how many we've placed, what our parent is, a template mesh, a mesh size you want, and it goes through and it stamps them down. For each one, what it tries to do is it tries to reuse an existing tile that exists. How do I do that? It's basically instancing these things. And then once it's done, it goes, so it tries to find an existing one based on the index of the child, and if there is an existing one, it reuses it, and if there's not an existing one, it creates a new one, adds a mesh, which is a template, a clone of the template, adds it as a child, and returns that guy's spatial, and we count how many we placed, and then down here all the ones we don't want we delete. So it's a way of optimizing the placement of tiles, so that if I keep on recreating floors with a similar number of tiles, I'm only asking Godot to move them. I'm not asking Godot to recreate them from scratch every time. So that means that adding small amounts of floor to an existing floor build, when it places, God, this is bugged out now, when the integration is working. And if I was to show you why the integration is not working, it would probably make more sense. It's just the synchronization is not working. There's a crossbeam event queue that's sending events from the game back to the Godot integration. Yes. So what was I going to do? What I'm considering doing tonight was switching from my first ever my first networking used something called Cobalt as a network, which is like a UDP transport layer server, and when there was something to send, how do I demonstrate that? I can't imagine showing you some code and it making sense and it being interesting. Anyway, I was thinking of switching from Cobalt to the one that comes with Amethyst. Which one were you thinking of? And refactoring the code around that. Amethyst, Rust. I'm feeling a bit shy. Anyway, I'll just keep trucking on. So, what are we trying to do here? Amethyst. So yeah, we've got 3 people watching. Welcome to my first stream, etc. I'm glad you've come by. I hope you like what you've seen so far. If not, I'm watching the chat, so and I'm taking requests of what to talk about, so please say something and I will address you, or just point out that what I'm saying is dreadfully boring. I'd appreciate that. Okay, Amethyst Network. So I initially considered Amethyst networking for my game, and at the time I thought it wasn't mature enough, and I wanted to do the low-level stuff myself, and kind of those two things combined. And a year later, it's had another year of development. It's still alive, whereas the one I chose to use originally was dead when I first started using it. This one called Cobalt, and because it's dead, it's like many years old, which means it's not getting nice improvements. And the Amethyst networking one is more high level, and it's designed. It says here it's designed for specs integration, so it's on top of specs. I'm not sure exactly what that means. When I look at the source, so you got simulation. I mean, the easiest way to jump into this is probably to actually check it out. So let's just do that. So see game dev lib. Where are we? Start factory learning. That's right. So I always check out all my code in here. Have I already put something in here for this? I'm glad I didn't spot anything I didn't want you to see. Anyway, some terrible networking library that's made of dark powers. Amethyst networking. Can we clone this? Amethyst. So I've already got all of Amethyst cloned, I think. No, not in here. Okay, so let's grab all of Amethyst. So clone or download. Grab this here. I use get extensions just to save me some trouble of typing these on the console. So I want this path to go in learning with the name Amethyst, personal repository, clone. So, nice fast fiber links. It doesn't take too long to download this. Threading progress bars. I should install Progress Quest to watch. Anyway. That's right. I'm hoping that I can create some games that use some good crates and hopefully bring some publicity or whatever people are using. I've certainly managed to shine a bit more light on the Go.Rust crate, which was really nice. Makes me feel good, and also it's to my own personal benefit, obviously. That's right. Feed all your attention into the crate I'm using. Okay, let's open a new window. Open. Paste this in. I want to open it in a new window. And I have pasted in the path to a different thing. Open. I don't want that path. I thought I'd copied the one from the learn that we're working with. Learning Amethyst. Paste that in here. This window. So we're just going to quickly look at the Amethyst examples, especially the one to do with networking. Look at the source and simulation. I want to see what's going on with the lib, which has simulation in bytes. Okay, simulation. Okay, component synchronization, matchmaking, etc. So they don't have anything there yet. We have transport layers here. We've got laminar, TCP, and UDP. So we're going to be using the laminar layer most likely, which is UDP plus a bit extra. Oh, I'm really glad things construct. I appreciate you saying things. It makes me feel a bit less alone. So the laminar contains all these different things. Simulation event delivery requirement network simulation time, I probably would be beneficial for me to just quickly bring up the Laminar docs here. So it's going to open a new tab. Bring up the docs for Laminar. And then it's based off Gaffer and Games, which is like really excellent web. Oh, it's back! So glad. This website's been down so much lately, but if you're interested in networking, it is a wonderful, wonderful, wonderful resource. Let me just quickly post a link into my. You should join this Discord. If you're not here, why aren't you here yet? Game Dev, Gaffer on Games, I love you. Anyway, there's a link. So Laminar. So what it does is it sends reliable messages, unreliable messages, both over the same UDP stream. It can even combine them into the same packets, I think. It can handle multiple streams. It does all the retries. It can also throw away packets. One thing it doesn't do, unfortunately, is if you send reliable packets, you can't change them later. It doesn't combine them the same way as I'd like them to, but maybe I could just use it and then write my own stuff on top of it that does some of that stuff. It was because I wanted to control the internals of how Cobalt was talking and take advantage of that to reduce retries that I actually used Cobalt in the first place and modified it. My mods are pretty minor so far. System bundle, how is this created? TCP, so you've got TCP, UDP, events, messages, requirements, timing. There doesn't seem to be a working example here. Which then makes me wonder if I was to search for, there's a search window that's come up on my other screen. So Amethyst, we want all of these, open them in the find window down the bottom here. This font size is really small, sorry about that. Amethyst network. Use Amethyst network as network. Okay, so that just means that when you're importing Amethyst, you will find Amethyst network as a network module of Amethyst. Okay. So the next thing is, does that mean if I look in the examples for Amethyst, I will find a network example? Net client, net zip. Oh, thank you. Amethyst network simulation, TCP network bundle. Okay. What are you doing with the network bundle? Default with bundle, grid listener, spam receive bundle. Okay. I don't know how these game bundles work because I haven't been looking at how Amethyst works. So the question is, do I want to use Amethyst network or do I want to use Laminar directly? And since Laminar is this version of Laminar here, 0.3, is designed to be used separately, whereas if I used Amethyst network as part of this whole thing, it's all integrated. What have we got in here that's useful? Events, messages, requirements, timing. These are just wrappers around what Laminar provides. Timing, transport. Yes, what I wanted to show you I got distracted. In here in Laminar was if I went back to its, where are we? Git. And then I go from here into a Laminar book. And then I go into reliability. There's this really nice little options of how you want packets to be sent. So you can, yeah, I know it's impressive. I agree, weird constructor. It's a good quality level, and that's what honestly, that's the most important thing, is that I can trust the source code. I don't want to have to look inside. I want to be able to just build on it. So let's just I think we can make a decision that Amethyst network as code is just a quick wrapper for Amethyst to make it binding, and it's only work in progress, and it's probably going to be amazing when Amethyst is ready, but it's not ready for us yet. Yeah, well documented crates less common. I agree. I've done pretty well, and the source code's been pretty good. I've got in the habit now of actually constantly downloading the source code for all my code. So if we look in C drive, why am I going back there? Star Factory, Rust, lib. I have my own versions of my main libraries, and I actually try and push things upstream. For instance, I found some bad examples in specs physics, so I push those upstream. It just makes it a lot easier for me to make the small mods I need. Or in Go.Rust, I occasionally find a bug, or there are some things that aren't written yet, so I've written some extra wrappers and stuff, which I've put in as patches as well. So being able to read the source code makes up somewhat for the bad documentation, but it makes life a lot harder for sure. So we just assume we're going to use Laminar, and if we do, we're going to use it as a library. Well, we're definitely going to check it out into the learning folder, because that's what I always do, because I like to read the source. So learning Laminar, we've already got a version checked out here, so let's just update this. Open the repository. Good extensions opens over here, and we're just going to do a quick poll. And wow, thank you so much to people who made Laminar for adding all this extra stuff. Check out. I made changes. Why did I make changes? Oh, yeah. I noticed some problems. I was feeling too shy to actually commit those. Okay. Let's make a quick commit. And then we'll rebase that commit on this. And it created some conflicts, which is not particularly surprising. Solve conflicts. Let's have a look. So quick look at the next. The first conflict is okay, so they didn't spot the spelling problem. So which one do I want? It's the base. This is the base here. This will be the new one here, and then we'll just quickly put my fix across as well. So set up our client. Whoops, wrong one. I am trying to put the changes in the bottom. Someone's deleting code, which is the best way of fixing code. Great. So they've got this. This is the test server to receive data. Anyway. Save. And we'll merge that. Oh, they deleted it. Well, use this. Okay. Continue rebase. Okay, so that created a simple commit on here, diff, which fixes the spelling mistakes. Let's just very quickly push that up. So I don't think I have a fork currently committed to GitHub. Let's just check. I want this private to show, so I'll just put that over here. No. So here's a Laminar. Let's make a quick fork. Fork. In fact, that's not the one I wanted. Remember this? Here we are. We fork this one. Yeah, I probably should go to my repositories real quick and just delete that other one. Where are we? Me, repositories. probably in here. Yes. And I want to find a way to delete this. I can't bother figuring it out right now. Lemon R1. Okay, so clone or download, grab this link. Go in here, go to push, manage remotes. I'm going to create a new remote. This one's going to be called Tom. Save. Yes. Configure. Okay. Close it. So we're going to push to Tom. Push. Yes. All takes so much time, doesn't it? Okay, anyway. So, this is here, and we're just going to quickly make a pull request. Again, just check this makes sense. Why am I asking them to change their client address? Probably don't want to ask them to do that. I probably did that by accident. Open this, and we want to open with diff tool, the first to, no, not the first to select it, that's not what I wanted. I just touched the cable, sorry that. Open diff tool, first to working directory. We'll just quickly wipe out this change here. Save that. Commit, amend, this one, commit, yes. Push, well, how do I force push here? Anyway, push, options, force push with lease, master to Tom. Coding is so boring, isn't it? I hope you're not getting too bored. Okay. So now it's got some quick spelling fixes here, and create pull requests and 1 spelling fixes. Great. And now we'll decide if they really care or not. But my conscience is free to explore their source code now. Okay. Finally, let's get into the juicy stuff. So, C drive, gaming, learning, amethyst. This is this one I had earlier. Open. We're going to quickly open the Laminara one. This window. Source bin, infrastructure, net, packet, okay, test utils. They haven't committed any examples here that I can see. Tests, common. He's tiny, just tiny, right? He's bothering even me, and I'm looking at the actual monitor. Mod client. How do we create a new client? It keeps going ding dong and then telling me that I'm running out of disk space. I'm sorry about all the loud noise. Anyway, maybe since I'm not using any noise in this, I should turn down my noise settings. Let's find OBS and just turn that down for you. You don't have to listen to my computer telling me that I have no disk space. Now it goes ding, you won't hear it as much. Okay. Client run instance. Runs an instance returns a client handle. What is a client handle? It's a thread handle, which is a join handle. Okay. Join handle is the one from rustlib. Okay, so it really is just a thread handle. Okay, so this is irrelevant really. Timeout, packets, handle. You're going to create a new thread, create a socket to bind, listen, for each packet we sent it to who. Okay, so this is a test client that starts up, creates a thread, sends a bunch of packets to a specific address, which it then use inside a test. Fair enough. Okay, so let's see where that's used. In the tests, I imagine. Where are we? How about I just try and, rather than read the source, we go to the other source of truth, which is their website, which I imagine actually has documentation on it. So let's just try that. Intro. Contributing important notices, protocols, heartbeat, fragmented reliability. Okay, so this book doesn't contain any information you'll need to actually do anything with it. How do we get to Laminar? Oh, this pull request, nothing's happened. It's just the automatic checks are passed. Okay, so Laminar, good. RS. Laminar udp.rs and master, but we don't want that. Ooh. Okay, so this version of Laminar in the Amethyst folder has examples in it. Why can't I find them here? Oh, of course, they're not in the source folder. Here we go. Server client. Give us an IP address. Function server. Function client. Main. If it starts with an S, it calls server. Otherwise, it calls client. Okay. That's pretty easy peasy. So let's just quickly jump into this folder. Copy path. For those just joining us, I'm just playing with Laminar because it's a networking library and I'm considering replacing my existing one, Cobalt, with Laminar. And goodbye. Rust. Run. Oh, it's not Rust, it's Cargo. Cargo run. Example. We want the one called server client. Build. Using up all my free disk space on C. Let's see. Okay, so I see a whole bunch of things saying it ran out of space to find an allocation, which basically tells me that I just ran out of space on my C drive. Okay, so let's go very quickly see if I can free up some space on my other drive. And then we'll try this again. I didn't realize that my building used up space on the other drive. That's really interesting. Maybe I've got, I probably set up a temporary folder in there I forgot about. So we're just going to watch a server or client demo. So here's a server, so we're going to run server. Even S is good enough. Okay, so it is unable to open a port, and the port it is unable to open was 12351. And could it be that I decided to use this port for my own networking code? I don't think I did. I'm pretty sure I used a different port. So then the question is there some permission that is lacking? I'm just checking that I didn't type that port number in. Ha! Oh, look at that. Yay. See, the story goes, Tom starts off by using the Laminar demo. Tom makes network game. Tom switches to Cobalt. Tom never changes his server port away from the example. That was Laminar. Tom comes back to run the Laminar demo and his server is still running and now it blows up. Okay, anyway, let's just quit the server. And this example should work. Yay! Server. Starting server. I imagine it's now running. Let's have a look at this path again. I'm just opening a second command prompt. Going to the same blues. Cargo run example. There's. I don't have to scroll up before. Client. Hello server. And you can see that worked. Hello server. Silence. Hi. Server sent. Copy that. I see. So what it's doing is it's only showing the output on the client when we receive the next message. Okay. So I'm thinking to myself, okay, I want to switch from Cobalt to Laminar. If I want to switch from Cobalt to Laminar, I'm going to have to check out Laminar. I'm going to have to either use Git or I have to use the cargo mechanism. So Git being putting a copy of Laminar essentially in my own repository. I don't see myself making a huge number of, well, that's not true. I see myself making quite a few mods to Laminar if I'm using it all the time. Yeah, and if I'm doing that, I really do want to fix that repository problem where my repositories have weird names. So I'm just going to quickly go back to my repositories, and it's on the other screen because I'm worried that I might have something that you could read that's revealing on this page, but I don't mind you kind of seeing the page overall. My repositories, which is where I am. I'm trying to figure out how to modify these. I think I can get rid of, because what I did was I cloned the wrong version of Laminar, so now I've got two versions of Laminar. I want to delete this repository somehow. Delete settings. Options, template. There'll be a delete option somewhere here. Danger zone. So we're deleting the Laminar repository from Tom Lee's settings. Delete this repository. Delete Laminar. Silent again. To GitHub. Confirm. Gone. Okay, my repositories. We're going back there. Again, I'll probably just expose something really important that I shouldn't have shown you, but we'll just go with that. Laminar 1. Here we are. So I want to go into settings for this. Its name was being used, you see. So I changed this back to Laminar. Rename. So now this has a nice name rather than having the Laminar -1, which I didn't really like. Clone or download. We're going to copy this path. Okay, so we're going to create something called a submodule. In Git, if you have a repository that belongs to you, you can actually create submodules from that repository, and they contain more code that is from other Git repositories, and you can even choose which commit you want to track. And so that means every time you make a commit, you can choose whether you update or stay in the same place. And it means if you go back in time in your repository, you go back in time in all the repositories you depend on, which is like awesome if all the repositories are changing all the time. It's kind of like version numbering, but on a commit by commit basis, so it's like really cool. Open repository. So bring up this dialog again, and we're managing the submodules, which is this dialog, this little submenu here. Let's update repository, manage submodules. Add a submodule. Submodule is the path that's Laminar. We're going to put it, not going to put it in the Laminar path. We're going to put it in rs lib Laminar. RSLib, Laminar, branch, it's going to be master, but it'll figure that out. Add. So it goes and checks out Ugh. Have I already ignored Laminar? Okay. That's really interesting. I didn't realize my good ignore file ignored the Laminar folder. I must have put that in there in the mists of time, before time itself. Let's see. Good ignore. Secrets. It's a Gush reference, by the way. SG target, yes. I don't get it. Okay, let's try that one more time and see if it comes out different. Add submodule. So we want to create a local path, which is rslib space factory. And the path we want to use was in Git, so we'll just bring up the Git browser again. And we're going to copy this path here. Copy, paste. And it's forgotten which path I wanted. RS. It doesn't have a /, so it's got rslib. Maybe it was that slash that screwed it up before. Add, like it was in the root somehow. Yeah, that's working now. Okay, so what that did is it's checked out Laminar and it's placed its source code in that handy dandy place I just told it to, which is in Star Factory rslib Laminar. It's now here. And what's more, if I go into Git extensions, I can see Laminar's tree is here, and you'll see that the commit that's chosen is my master one, but I can choose any commit I like. And then if I go back into the parent one, when I next commit, one of the things that's here to be committed is Git modules contains a Laminar, and also this is how you change the commit of Laminar. So everything is awesome when you put over team. Interesting, well, the PBR play has created new materials, which is why Godot took so long to start. But I don't actually want any new materials. These would all have been created when I was browsing and showing them to you, and I didn't even realize because they're automatically updating. So I'm going to revert all those files. Reset. I don't want those new ones. And it's busy deleting files and taking a long time. Reset. In fact, that reminds me I probably should quit Substance Designer because it's an intense application and I don't need it running. And also Blender, which I used to show off asteroids earlier. Discard. Okay. Probably don't need these import files either. Reset those. I changed the ship route. Oh, I did actually remove some Omni lights. I don't want. Okay. So we've got 3D route has changed so that something wasn't folded. I don't really care about that, but I'll put it in anyway. Remove extra scene lights on ship. Rocks. What did I do to these? I moved a rock to demonstrate something. I think I put a light in it as well. We don't need to change that scene. And we don't need to change convent box scene. We probably don't need to change this scene either. Yeah, we don't need to change the 3D route scene. Great, so just some pretty simple, straightforward. Moved extra scene lights on ship and Laminar submodule. That's a very good question. Weird constructor. So the question was, what functionality do I want in my game for the minimal viable prototype or core game loop? I'll answer that in just a moment. Let me just finish this off. Continue. I don't care about committing outside of a branch. What we'll do is we've got master, which is that whip. We'll add a tag here, create a new tag here saying whip player input, because that was what I was working on there. We're going to reset the master to here. Reset current branch. I'm not sure what current branch is. We can do hard because you've got no local changes. Yes. So the master branch. We haven't checked out a branch checkout. Oh, before I check out a branch, Oh no, I just lost all my work, etc. No. I lost a commit. Okay, anyway. Repository. Git maintenance. Recover lost objects. Look at these. Dangling commit. It's probably hash. Where's the description? This one here. Recover selected objects. I need to tick a tick box first. Think. I don't know why it showed that again. Done. Get rid of this. So let's put a tag on the one that I accidentally lost. Anyway, reset current branch to here. Doof. Okay, what functionality do I want in my game for the minimal viable game loop? Okay, so if you look at, let me just quickly bring up Medium and go to my my stories, and then I go into Tale of Conquest, and I scroll down through a wonderful fiction story that I wrote, which makes it awesome, and into key features. Now, the game's actually pretty audacious and ambitious, and it's going to take quite a long time. The absolute core loop is going to be collecting asteroids, turning them into something, and improving our ship, right? So that's the minimal product. So what I'm concerned about right now is all the current features need to be multiplayer, because I'm happy with that. Those are features I want. I need to allow player movement to be synchronized. I need ship movement to work. Then I need to add asteroids so that you can fly around. That scoop that currently creates gold as a debug feature will need to turn asteroids that are small enough into items on the conveyor. You'll need some way of breaking asteroids into smaller parts. It could be that actually the front of the ship does damage and breaks them anyway. It could be that I put a weapon in of some kind. You need to be able to build something. Things need to have a cost. And then I need to run the server and spread a game client around. People should be able to fly around, clear a sector. Pardon me, I'm getting really... should be able to fly around, clear a sector, and build ships. And every half hour, an hour, the game resets down the track a little bit. You build a ship that's bigger and better, and you go to warp. So I was thinking like a race. So you go to a sector, you mine it. When you've got enough resources and you're happy your ship's big enough, you warp to the next sector where other people are already mining, and you try and have checkpoints and hops, so 3 sectors, mining each one, building your ship, so that would test multiplayer. And it's basically, the idea is to try and make something that's fun for people to play, so that people will come and hang out on the test server. And over time, there'll be more and more to build. You have more reasons to not just do the mining game. Will start having a reason to want to build stuff, and they'll be big enough, and there'll be enough different items to build that you start wanting to build stations of your own, have your own reasons to mine to build a station, and then we don't need the mini game to justify it. So functionality in the mini game: flying ships, mining stuff, upgrading your ship. That's the loop. Oh, and spending your resources on something else. And there's a whole AI thing that you're going to have later on, the AI menace. There's sector generation. But again, both of those things are like, they don't need to be there for the MVP. And to a degree, the game's kind of already proven the most important thing for me in terms of MVP, which is that people actually care. It doesn't look so ugly that people aren't engaging at all. So as long as that's the case, I'm actually pretty happy. I've got some followers, got some stuff going on, got things which are pretty enough people to look at, I've got upvotes. That physics one got a lot of upvotes. I was really happy with that. I know it says 19, and like most people are like, 19 is nothing, but to me that's a lot. So thank you for voting. Anyway, that is my core. Mine, upgrade. It's like kill enemy, take loot, improve character. It's the same sort of loop. Star Factory, we just added laminar. Next thing we're going to do in server, this is the example. So I'm going to just put this example on my other monitor over here. So this is kind of out of my way. It's only a bit late, I might stop in like 15 minutes or something. Here's RS. So if we have a look at the repository here, we've got multiple different libraries. So if I look in SG and I look in here, I've got 4. I've got this one's called SG Core, this one's called SGNet. This SG stands for Space Game, of course. We've got SGNet, SG Server, and SG Simulation. So the game proper is mostly in SG Simulation, but SGNet is where I've got the network code. And you can see 4 files: client, connection, lib, and server. And the network knows enough about simulation to create it, and to feed messages through. And no one else knows about the network apart from SGNet. And in SG Core, which is the Go dot initialization stuff, it knows there's a network because it's creating an instance of the client in order to connect to the server. Which of course is a really nice abstraction now, because all we have to do is create a new version of SGNet that uses laminar. In fact, we could go so far as to create a copy of... in fact, I might just do exactly that. SGNet, how do we do this? So SGNet is a crate order stands alone, and it has in it the example, I think, or I just made it so that, how did I do that? Core server, oh that's right, so net is a library and then server is an executable that can be run as a client or a server actually, and it just instantiates one of those. How much do I want to make a copy? I can always just use get to make a copy later, so let's just not worry about that right now. So this module, SG Simulation Cobalt, so the Cobalt path is Cobalt RS. We don't want that anymore, we want it to be laminar. And this is laminar. And if I go into client, well, we can't use the Cobalt here. In connection, we can't use this Cobalt here. We have these Cobalt server and client classes. Why did I want those? I can't remember. Oh, of course, they'll be to export to other files that are trying to instantiate those. So they're kind of like nice types for later. We'll put those aside with comments. Lib. So we get a client, we get a Cobalt client and server, we get a server, we grab something called config, which I don't want anymore. We go down here a bit, we start clients, which is running threads. If it's running a server, then it grabs the default config. It's running a client. Okay. Server. It knows about Cobalt connection, Cobalt server, center tools, connection ID and server event. Other than that, it doesn't know much. So it seems like both of those are actually pretty light, not tightly bound to what's going on. If we look at what's server, stack ID, client lookup, client table, new lookup connected client, using connection ID for this. Lost client, handle messages, process incoming, which is called for each message. Tickable. Where's process incoming called from? Server client lib. Yep. So inside here, when we run a server, thread config defaults. We create a new server, which we call UDP. And then in this outer loop that the server doesn't really understand, we pass it the UDP, and then we do a tick, and then we ask it to send us outgoing messages. And the most important thing about this is the interface that Cobalt server has, accept receive. This allows us to look inside a connection, track when it loses clients. Okay. Ooh, there's so much stuff to worry about. Okay, so we want to open, and how are we going to do this? We'll close everything else. Close all those. We'll make this smaller. We'll grab this other window here, put that on the right side. This is going to show us the example. The example is server client. IP address. Okay. So the server opens the socket, binds that. Get packet sender, get event receiver. So sender and receiver are these really nice wrappers that it's not the sender I thought it was going to give me. As far as I understand that they are if I look at get packet sender, it returns a sender class. Sender is part of channel, which is in crossbeam. So what it really is a multi-thread communication that passes your packets back. So automatically it's starting the server in its own thread, as far as I understand, based on a very, very quick look. So we'll ignore the server class right this second. We'll jump back to lib. We'll have a look in run server. I don't think we need a config. We don't need that. So the UDP is going to equal. It's going to be creating a new socket bind. Okay, to the address. Yeah. So here we listen. Okay. So here we use socket bind server, and it returns an option. And if it doesn't return an option, we're going to say failed to bind to server. So that line has got a straight up copy and paste replace. So in case you're not following, what we're doing is we're moving from Cobalt to MNR. So I just told CLion that I wanted it to resolve a missing symbol, and it's figured out that I wanted a laminar socket because there were no options. So whenever I type in something that, if I delete this line and I save and I wait a short while, Rust is going to tell us that this is not found. That goes red. And if I alt enter on this, I have an option to import. And when I push enter, it automatically imports it up the top here, so I don't have to worry about finding where it's from. And if there are multiple options, it will ask me which one I wanted. So bind to the server port, listening. So I want this line to be down here. Once I have opened this, I can get my sender and receiver. So in this case it calls it socket, so we might as well call this socket as well. And so sender, receiver, server, we don't need. Oh yes, the server class is the one that we have designed. Build sector, static sector. So these here have build static sector creates a couple of spaceships. So given an empty sector that contains worlds, we tell the sector to give us the world ID number 1. It creates one of those, which is the first ship. We add the ship map, which is this map, so that's like a conveyor layout. to the ship. So you'll see this little kind of ASCII art thing. And then we add some floor. So left, right, top, bottom, that's a square or rectangle that defines some floor. And then here's another one that we delete. And that defines the first ship's shape that you see when the game starts. And then we determine its bounds. I'm not sure why I determine its bounds. Yeah, probably for debugging at some point. And then we do the same thing for a second ship. So we've got 2 ships. And then down here we create test starships. It calls up to this one. We create a world called Space World ID, which is always ID 0. And then with that world, we add 2 spaceships at the 2 locations, minus 18, and minus 18.5, X and Y. And go dot, that's X and Z. When we add spaceships, what we do is we given a particular world, there's the X and Z locations, there's the bounds. I don't think the bounds are relevant here. Yeah, I just say the ship is 0, 0, 10, 10, but later on it's going to be calculated. We create a new spaceship at that location. We specify where it starts. This pos isometry is actually physics. It's a physics location. We create a physics body and we give it a velocity. This is why the ships are drifting, is because of this statement here that moves them sideways. So if I change this number, they would drift at a different speed. And every tick they're drifting, you see. So it was just there to prove that physics was working. In fact, since it was just a test, I might as well make that 0 now. That's kind of annoying. We create a cuboid shape so they could crash, but we can't control them by hand, so we can't cause them to crash, so we can't see it. Change them to over 9,000. I could create another branch, and I could run the game in that branch, and then I could deliberately set them on a collision course and make them crash into each other, and we could watch them go spinning out of control. Why would I possibly want to make something that's worth watching? It's not like we're streaming or something. We'll do that next time. Okay. Okay. Because I can't run it right now, so by the time that I run it, I'll be like, what the hell, where'd the ship go? And then I'll think it's a network problem. Anyway, I can't wait to play with you and you like fly your ships into mine, yay. And I could crash and smash and push around, it'll be good. So that's how the world is made, in case you're wondering. Don't trust Genesis. Anyway, so, sector. So this is a loop where we actually process messages, and so when we process these messages, we're going to process incoming. We're going to be using the receiver. I'm not sure if it needs to be mute, and when we're sending, we'll be sending via the sender. And at this level, that's all it takes. And let's just quickly remove the ability to run a client from here, because actually that'd probably be quite silly, because it'd be quite useful for testing. So but yeah. What that means is I'm not sure. Okay. Let's say process incoming, do text. So this is red because it's the wrong type. So how do we process incoming? Well, our UDP we expect here is not Cobalt server. In fact, let's go back to this type Cobalt server and call it receiver. No, we'll just deliberately use exactly what the types are. So we'll copy. We can't copy and paste from the screen where it says receiver socket event. What we can do is go to get event receiver, and we can call receiver socket event, and we can paste it in here. And then we're going to go down to this other one that is for sending outgoing, and we're going to replace this with send a packet like this. And then we're going to just quickly do this for client, because I'm in the middle of doing it, might as well do it now. So send outgoing, click client. This process incoming, going to be receiver socket event. Now, I'm assuming, of course, that we don't send stuff when we receive things. And one thing about connecting is that you might have some reason why you want to send stuff straight away. Like, hello. But I don't seem to do that here. On the server, do I do that? Process incoming. UDP. How do I use it? Accept, receive. Connection unwrap. Yeah, I don't seem to send anything when I'm receiving, which is wonderful, really. Great. Okay, so a quick Alt-Enter on here will fix these reds. Import receiver from... Oh, of course, where... in order to import receiver, I need to make sure that I have crossbeam. So to have crossbeam, I need to find out how this guy's getting crossbeam. So if we just quickly open this up, I wonder if they're exporting it. No, they can't be, because it would have realized. So cargo toml crossbeam channel is the one we want. So this is me copying from the laminar library. Go into the network code, into toml, and we're going to just quickly put crossbeam channel in there. So now the Space Game Net package has got crossbeam in it. Connection. Where am I? I'm confused. That's right. So in server. Now that I've done that, if I go receiver and import, I should see crossbeam in the list of things that I can import from. Socket event will be from that other library, and sender will also be good. We'll have one of those, and that's from crossbeam channel, and packet is from. So now we've got, it's just gone and added these two lines for us, but it's just so convenient, I can't resist. Yeah, this is stream my plan of how to keep the server safe and what its dangers are. That's a really great idea. Anyway, look at connectors, handle messages, process incoming. You're probably quite enjoying this very trippy view of my stream window on the right hand side here, the little box at the bottom. Oh well, I'll just hide that and then it won't be so trippy. And you might have noticed that I've got a view of my Twitch on this other side that is showing a time delayed version as far as you're concerned, because it takes a while for it to round trip to the server and back. It's possible that I can get away by closing that as well, but it gives me some degree of confidence that everything's working, so I'll just leave it up for now. Let's see, server. Process incoming as a receiver. So the next thing to look at is how does the server client actually process an incoming message. So it receives socket events. Socket events can be packets, connects, and timeouts. So when we have a UDP here, we ask it to accept receive. So when we have it here, what do? We use receive. So while it's saying in a loop, well, they want to loop. Okay, so if it says goodbye, we break. Well, let's just ignore that for now. Oh, I see. This is blocking the thread. That's what's going on here. We don't want to block the thread. So we want to poll try receive. That's exactly what we want. So either we receive a message or we return an error, which is wonderful. That's probably the best option. And I believe if I look in, have a quick look in Rust, let me just run the Rust documentation, which I can do by, we're going to close this, and then we're going to Rust up docs, which runs a local version of the Rust documentation, which we'll put here. We'll just grab the other browser. So I need to put this one on top here like this. Bing. And then we're going to go into standard library, and I'm interested in looking at result. which is the error version. For some reason it's not here. Result. OK or error. I believe it has got a routine called OK. That returns an option. Wonderful. OK, so I am trying to figure out the best way to unpack these. It might be best to just put it in a straight up loop. Yeah. Okay. Let's go. So, well, let OK event equals accept receive. Well, actually, we've already done the unwrapping here, so that's easy. So we just need to put try receive here. And this shouldn't be called UDP, it should be called receiver. So shift X is a rename. RECV. Sorry about snorting into the microphone, by the way. Try receive event, match the event. So in the case of Cobalt, there are three kinds: connection, message, and connection closed. If we have a look at packet, we'll probably find similar. Receiver socket event. So we've got a packet is a message. It's very interesting. The packets have IDs in them. Socket address. I see. These are the kind of problems that I had with it before. Was that it is more interested in a socket address than it is interested in a client ID, whereas Cobalt had this really nice mechanism where it would actually check a client and it would deduplicate. So my ID numbers were easier to manage. Whereas now I'm going to have to do it based on socket ID, which is in socket address, which I believe is yeah, it's the Rust one. So less than ideal. So here I've got these connection IDs, and instead of connection ID types, I'm going to have to use, and I don't think I've even defined it now because I removed connection ID. So what we're going to do is we're going to make a type at the top here, or in lib, put in connection, and we'll make a connection ID, and it's going to be the same as the one that it's using, which is in packet, as a socket address basically. And it's going to go red, and we're going to fix that. Come on, go red. Here we are. Import. So it grabs it from standard net. And then in server, we're going to grab that out of here. And so we've got connection ID. And then all this code down here that's already working with the connection IDs should just keep going for now, even though I really dislike the way that if a user, when IP addresses change, the people won't trade across them properly and that sort of thing. People on mobile networks have their IP addresses change all the time. And so we're going to have to manage that at some point. Server, client ID. Where was I? That's right, I was in process incoming. Which event connection, it's an ID, where we are. Why did I want connection? I wanted its peer address. Well, fortunately that's the same as the ID anyway. I don't even need that now, so I'll get rid of this, I'll get rid of that. It's round trip time. I don't know how to tell that anymore. I bet there's a clever way of doing that, but I don't know how, so I'll remove that as well, and then I will change this to remove that part of the string so that will compile. Next one is event, is message. Messages are packets. So it's not called connection, that's called connect, and it's a socket event now. So the socket event packet. So if we look into packet, we can see that it's a class. and what we want is the ID. So if I just change this into a nice curly bracket, we can use Rust's unpacking, which is like super cool. So the address is ID, and the payload is the message buffer. And do we care how it was delivered and ordered? Not yet. And then we didn't do all the fields, so we put a comma, and then I think it's 3 dots and 2 dots. Yep, awesome. And what that has done is it's told Rust we don't care about those other missing fields of the struct that we haven't unpacked. I don't know why this is red. Okay. Oh, I know. We're unpacking an enumerator packet. Inside that is a packet. And it's the packet we're trying to unpack. And so I need a round bracket and then a curly bracket. So we unpack the enumerator, get out the struct. And this one also needs import. No, it doesn't need importing. Okay, great. Handle messages. What's it expecting for its message buffer? It expects a vector of U8s. Okay. I'm pretty sure if I pass a pointer to U8, it's a box pointing to an array of U8s. I'm pretty sure I can make a vector out of that. Only because I want to... Yeah, I can't be bothered changing that code right now. We will make this more efficient later. And so the way we'll make it inefficient now is we'll just going to make a vector right here and here and now. We should go to a vec, and there'll probably be a new from. So let's just have a quick look at the documentation. Pushing S on any page of documentation jumps to the search, and you just type in what you want. So I want vec t, and there'll be a new from slice somewhere here. Ah, God, I was supposed to have stopped by now. Thank you for motivating me. Okay. Vec extend does that. I like this streaming thing. It's very motivational. I can tell you that for sure. Extend from slice. Obviously I create a new vec, I could just call extend from slice. There's a lot of it, yeah. I can't be bothered figuring out if I can make a better way of doing this, so I'm just going to do this vec new dot extend from slice and pass it in. That. No. Yes, that doesn't do it in place. Okay. Clone from slice. Just trying to find a better from slice because I didn't like the other option, but I guess it's just the best one anyway. Okay. Det. Buff vec equal vec, create an empty vector, and then we're going to use buff vec. It has to be mutable because you're going to change it. Slice, we're going to pass in the slice that's in the message buffer, so that's I think it's called a payload. Extend from slice payload. So now buff vec contains that entire payload, and then we can just... I think part of the reason why I used a vector is because I wanted to be able to delete the prefix in later code, and it to be simple, and it was easier to use a vector than to do it some other way. There's lots of awesome options in Rust to do things really cleverly in zero copy, and I think I'll go for figuring those out later as opposed to trying to do them right now. Okay, socket event. We've got the packet one that's handled, because from this point onwards it's just everything's normal. This is honestly when all the effort to make things really modular and not pollute your entire structure of your application with your libraries really pays off, because if I had references to Cobalt all through my code base, this would be really painful. Timeout. The client has been idling for a configurable amount of time. Okay, so it's just basically telling me that I have to send a timeout. I guess that's a particular client. Is this happening on the server? Is it like saying a timeout? Well, yeah, yes, actually it is. Literally says timeout. Okay, so we'll just use the timeout here. And I mean, obviously, you hope the timeout also occurs if there's a clean disconnect. Or maybe we just send a message like saying bye. We have to like specifically send a message when the client leaves, or we'll be relying on the timeouts. If there's a timeout event, then we find the connection. We say it disconnected. We're going to print the ID. We don't care about these two because I don't know how to get those. We delete all this. Lost client. ID connection. Go into that. It needs a connection ID and a Cobalt connection. It doesn't use the Cobalt connection, so it can forget about that actually. Poof. Who cares what the Cobalt connection was? Get rid of this con. That was a con. Send outgoing, UDP, send the packets sector. So it needs to get the sector, ask it to put all its packets into an output buffer for each client state and look up if the client is connected. So here's my current client states. It's very long. Connected, disconnected. I mean, you know, hey, you can't get much better than that. Anyway, so if it's currently connected, process incoming, send outgoing. If it's connected, then so I think here I actually try and find its connection. I ask the network system to give me a connection object, and then using the connection object, I do something good with it. I think this is just my way of checking send all. Yeah, see, this is just my, this is what counts. Populate sender. And I use this sender idea, outgoing, this idea of a sender queue. And then I use send all. How do I do that? Connection, what is a connection? I think this is something that I invented. The sender queue thing. Message kind message. No. This is actually something specific to Cobalt. A vector of message kind of messages, and then send all takes that vector. Yeah. So what we're trying to populate is a sender packet, which is this here. So this is just the crossbeam channel. So I'm just trying to figure out if I want to use populate sender to populate a vector, or do I want to use populate sender to write straight into the crossbeam channel. The crossbeam channel has the advantage that it's already a multi-threaded object, so it would be more performant if I end up splitting the process of actually adding packets to the sender. So, you know, you have 100 worlds and you add them in 100 threads, then it would work better. Which is pretty bloody compelling, really. What do I do with sender? So here's where I push a message to send. Sender. Oh, and then we push to it here as well. So we populate sender client. If this routine's called for both the client and the server. So we call populate sender client to send messages to the server, or we call populate sender server to send messages from the server to the client, and different messages get sent depending on which role the sector is, the world is in. because the sink contains worlds. This should be fun. I think I'm going to actually wrap it up around here. I appreciate you viewing me, both Weird Constructor and Mystery Person, who hasn't said anything in the chat that I recognise. I really appreciate you dropping by to watch. I hope you had fun, and I look forward to talking to you guys on Discord. Goodbye. I guess I pushed the button that says end the stream. Let's see if I can find it. Thank you very much. I appreciate the inspiration to actually try. And good night or good day, good sir. Let's see, where is OBS? Here we go. I shall bring up the giant echo chamber. We should go down to the coast and stop streaming.